Thank you, DG. Dear Honorable Ministers, Excellencies, Delegates, and colleagues, welcome to this special session on redefining the solar revolution, turning waste to worth. We have gathered here today to confront one of the most defining challenges of our energy future, ensuring that solar revolution remains truly sustainable across its entire life cycle. I now have the honor of inviting Honorable Minister, Mr. Prahlad V. Joshi, Union Minister of New and Renewable Energy and Consumer Affairs, Food and Public Distribution, Government of India, to kindly deliver his opening remarks.
Over the past decade, the solar revolution has been one of the humanity's greatest success stories. In less than 10 years, global solar capacity has expanded to nearly 2 terawatts, transferring the way our world produces and consumes the energy. India itself has increased its solar installations, becoming the third largest solar country in the world. The International Solar Alliance, born from the joint vision of India and France, under the leadership of Prime Minister Shri Narendra Modi, has been at the heart of this transformation, uniting 125 countries in a common mission to make the solar energy affordable, accessible, and sustainable for all. But as we celebrate this achievement, we must also confront the next frontiers of sustainability, achieving the robust supply and the access to the rare and critical raw materials to enhance the nation's manufacturing ability and end of the life management of solar panels and batteries. If not managed responsibly, the same technologies that power our clean energy transition today could become the source of tomorrow's environmental challenge. This is where sunrise comes in and solar upcycling network for recycling, innovation and stakeholder engagement, an initiative that embodies the next phase of ISA's journey and indeed the next phase of solar revolution itself. Sunrise transforms a potential waste crisis into a circular solar economy opportunity, one that can create the green industry, new revenue channels, secure the critical minerals through the recycling support, jobs and livelihood with upskilling, and make the value supply chain resilient, especially across the global south. This is also in line with India's national critical mineral mission designed to ensure the secure supply of critical minerals, including through recycling. Through advancing the harmonization of standards and policies, innovation and partnership, Sunrise will help the member countries establish regional recycling hubs, recover the critical materials, and promote the sustainable production and consumption. It reflects the principle that has always guided the India's renewable energy journey, that growth must not only green but also circular and regenerative. ISA was conceived for aggregating the solar policies across the countries, and by convening all 125 countries of the ISA through Sunrise, we are starting a historic journey today. I take this opportunity to commend the ISA Secretariat and its partners for their collaboration and foresight in bringing the sunrise to life. As we launch this platform today, let us reaffirm our shared commitment that solar revolution must be sustainable not only in generation but in regeneration, where the materials live many lives, waste becomes worth, and innovation light the path to a circular solar future. Thank you.
Thank you, Honorable Minister, for that inspiring address and the message, and that solar revolution must be sustainable not only in generation but in regeneration as well. So, Excellencies, colleagues, now we turn to a milestone moment, one that I truly am going to remember for the rest of my life, and I'm sure you will as well. It is an honor today to speak to you on behalf of International Solar Alliance as we launch Sunrise, which is the solar upcycling network for recycling, innovation, and stakeholder engagement. Can we have slides, please? So, we stand today at a defining moment in solar revolution. Over the past decade, solar has become world's fastest growing source of energy, electricity. Globally, we have crossed 1.86 terawatts of installed solar capacity. Within ISA's 124 member countries, yes, the analysis was done based on our member countries till June this year. We are strong and we are 125 member countries now. So for the 124 member countries, the share alone is over 762 gigawatts, which is about 41% of the global capacity. But with this success comes a new responsibility. Managing what happens after the sun sets on our solar panels and batteries is a responsibility that we need to look into. By 2049, these installations will generate an estimated amount of 124 million metric tons of solar waste. So to put that into perspective, the waste only from the end-of-life solar panels could weigh as much as 14 Mount Everest if panels are stacked together, combined. And that is the scale of waste that we need to plan for. So this is not just a waste problem, it is a resource opportunity, the size of an entire new industry that we need to look at, because within that waste lies more than 50 billion USD worth of recoverable materials each year. Silicon, copper, aluminium, silver, glass, the building blocks of the next generation of solar. By recovering and reusing these materials, we can reduce our dependence on imported critical materials, a key vulnerability of Global South. We can prevent toxic materials such as lead and cadmium from leaking into soil and water through landfills. And we can build a new wave of green manufacturing and skilled employment across recycling, logistics, and material recovery. So, in the heat of this challenge, the ISA has developed a forward-looking initiative, the Sunrise, the solar upcycling network for recycling, innovation, and stakeholder engagement. This global platform is operationalized under ISA's Program 8, Solar PV and Battery Waste Management, and mapped under Pillar 4, which is Technology, Roadmap, and Policy of our strategic vision. It connects governments, industries, innovators to unlock the hidden value of embedded solar waste, helping member countries turn end-of-life challenges into engines of new economic growth and sustainability. So, through Sunrise, ISA envisions a world where every solar panel and battery is designed, deployed, and recovered responsibly, where circularity is built into the DNA of solar economy. So Sunrise is structured around 6 strategic axes: policy and regulatory readiness, helping countries frame extended producer responsibility models, standards, and toolkits for solar and battery recycling. Pillar 2, which is data and waste mapping, building a global outlook and country-level waste forecasting tools. Pillar 3, which is technology and innovation support, advancing design for recycling, repowering, and second life solutions. Pillar 4, capacity building and awareness support, training recyclers, auditors, and policymakers, curating global best practices. Pillar 5, which is regional infrastructure and investment, enabling regional recycling hubs across Africa, Asia Pacific, and SIDS, basically turning potential waste into engines of sustained industrial growth. And uniting them all is Pillar 6, which is global community of practice of Sunrise. This is an open network for knowledge exchange, policy dialogue, and partnership formation. So this slide actually shows how Sunrise will actually operate through a structured, collaborative community of practice. It would be led by an international technical advisory group, and Community of Practice Sunrise Coordination Committee based at ISA headquarters will manage coordination, knowledge, and communication across partners. But what truly makes this partnership unique is the partnership ecosystem we are building. Research and academia bringing science and data. Multilateral and bilateral partners providing policy and financing support. Private sector, including recyclers, module and battery producers, and technology innovators. And industry associations, ensuring the industry's voice is central. Together, this forms a collaborative governance model where partners share insights, co-develop solutions, and shape decisions under ISA's leadership to make circular solar economies a global reality. So our goal at ISA is to make circularity not an afterthought, but a competitive advantage for all ISA member countries. So this is how Sunrise moves from vision to action. In 2026, we build the foundation, mapping stakeholders, publishing the Global Solar Waste Outlook, and releasing the battery recycling guidelines as early as first quarter of 2026. By 2027, we drive implementation, launching the forecasting tools, model EPR toolkits for member countries, and repowering assessments for PV and batteries. And in 2028, we scale up, expanding the community of practice, training auditors, and showcasing circular innovations across regions. Together, this 3-year plan turns circularity into reality for ISA member countries. So we also did a prelude to this community of practice and started with a 3-part webinar series this year, which had a participation from 580 plus participants and stakeholders from 86 plus countries, and 10% of which were non-ISA member countries. So we already have an interest from 7 plus interested stakeholders for developing this community of practice. So we are taking off, my dear friends, here. And let me end with this thought. For decades, solar energy has been about harvesting light. With Sunrise, we now begin a new chapter, one about harvesting value from what we once discarded, PV and battery waste, value from collaboration and shared innovation, and value for people, economies, and our planet. Through Sunrise, ISA is pioneering a new paradigm where solar panels and batteries live many lives, materials never go waste, and circular innovation powers a cleaner and fairer world. With this, I invite every partner, every policymaker, every innovator in this room to join the Sunrise community of practice to catalyze, collect, and connect for a truly circular solar future. Thank you. And with this, I would like to hand over to my colleague Mudabbir so that we can initiate the panel discussion. Okay. So I would request honorable ministers to kindly launch the video of the Sunrise platform.
Thank you, Honorable Minister, for launching the Sunrise and for setting the motion at this defining moment for the solar circularity. What we have just witnessed is more than a film. It's a vision for the next frontier of sustainability. What we just saw is probably the world's first coordinated platform dedicated to making solar revolution truly circular. My name is Mudabbir Anam, and I am the secondee from Germany working for ISA. We now want to move to our high-level panel discussion, Powering the Circular Solar Future, which brings together experts spanning from policy, finance, technology, industry, as well as development partners, the very pillars of Sunrise. Distinguished guests, please allow me to welcome our distinguished panelists. Dr. Henry Lee, Division Director, Industrial Technology Research Institute, ITRI. Dr. Henry, please come to the stage. Dr. Obhinav Mathur, Advisor of the Board, Atero Recycling. Dr. Shujata Gupta, Director, South Asia Energy Division, Asian Development Bank. Mr. Bernhard Kreuzberg, Project Director from GIZ. Mr. Rishabh Jain, Fellow, Council on Energy, Environment and Water. And I think our respected DG will also join as a panelist soon. Now I would like to invite Gulin from ISA once again to moderate the panel discussion. Gulin, over to you.
Thank you, Mudabbir. And dear audience, firstly, a huge round of applause for the presentation that I just gave, and the video we just launched, and for the panelists that are here. I know it is after lunch, and let's wake ourselves up with some claps. Thank you. So, I am very delighted to welcome our distinguished panel, which represents the pillar of this transition: policy, finance, technology, innovation, and industry, each bringing a vital piece of circularity puzzle. So, without wasting much time, I will dig right into it, and I would move into the first section, which is on policy and ecosystems. And my question is for Mr. Rishabh Jain. The Council on Energy, Environment and Water has long been creating evidence around waste generation, waste treatment, identifying markets for reclaimed materials, and developing financing solutions for circular economy. Even in your recent report, Making India a Hub for Critical Mineral Processing talks about addressing vulnerabilities in the supply chain of critical minerals. So what are the challenges that you foresee on turning waste to resources, and how organizations like ISA can overcome those challenges?
Thank you, Gurleen, for the invitation and for the opportunity. At CW, for the last couple of years, we have been working on estimating the waste that will be generated from solar modules. But the same goes very well with any other technologies in the clean energy sector, like wind, batteries, or EV. Last year, we came up with an analysis with the Ministry of New and Renewable Energy, estimating the waste of 600 kilotons that would be potentially generated by 2030, and more so going forward. One of the biggest challenges that we foresee, and in a report that we will be launching in the next couple of weeks, is that the logistical challenge of collecting the waste from the end consumer is the largest cost factor. Sorry. In our upcoming report, we analyze and we see that around 50 to 60% of the waste cost itself is because of the logistical constraints. Now, I'll give you some examples. In our analysis that we found that most of India's waste will be generated in 5 states. Some of these states are in the western part of the country and some are in the southern part of the country. Now, unless and until there are recycling centers that are set up where the waste is generated, it will not make sense for many of the recycling companies to then go and pick up, and sometimes pick up the waste and then recycle it. So that is one. In the recent analysis that we'll be also launching, adding this cost to the overall cost, it means that there is approximately $100 to $120, $140 of delta because of mechanical and chemical recycling. So there's logistical cost, then there's the cost of recycling, and if we add all of that in business as usual, it is of course huge. However, if there can be policy changes in a sense that maybe modules are available free of cost, or if modules are available close to where the recycling happens, some of these things can be made economically viable. Finally, what can ISA do? Of course, India, despite being one of the largest markets, this is such a huge challenge. So we can only estimate the kind of problems or concerns that countries which are slightly smaller and may not necessarily have the volumes, how should they tackle? This then begins to say that what is the role and how can we design business models, how can we design certain recycling centers that maybe disassemble, slightly recycle in locations that are close to the center and maybe then ship it to some other places. So business models that are adapted to the countries where the waste is generated is very important. At the same time, of course, the technology, availability of the technology for people to recycle. Of course, if I don't have a technology, I may end up using chemicals that are not in the best interest. So I think ISA can really help a lot of the member countries by providing them the necessary support, information through availability of tech, policy, and maybe some market design. Thank you.
Thank you, Mr. Jain. So, for answering that, which links me or leads me to the next segment, which is about technology. So, as we know, policy creates the guardrails, but it is technology that defines what is possible. So, let's move into the innovation side of circularity and talk about what Mr. Jain just mentioned, which is about disassembly. So, Dr. Lee, ITRI has been pioneering R&D from easily dismantled PV modules to high-purity material recovery. Beyond conventional mechanical and thermal processes, what new technologies are showing the greatest promise for rapid commercial uptake across different regions?
Okay, thank you. From Taiwan experience, there are three technological now moving toward to commercial application. The first one is high-value material recovery. The two is low temperature. It means low energy, low chemical, eliminatory process. The last is second life reuse and clarification. We view the circular design into three layers: modular, system, and project manager. Especially in modular level, we have to easy debonding for recycle. Easy debonding is a new design for modular structure by using a new encapsulant. For example, thermoplastic material, not thermal satin EVA material. Obtained like so. Through this new design, the material of PV module could be easily obtained like wafer, glasses, or very used for metal. The system level module reduced power waste. And the third project level is very important. While we decommission planning at installation stage at the first installation. Thank you.
Thank you, Dr. Lee. So thank you for highlighting different kinds of technologies that are used in lab and on the design side of the recycling process. Now, from lab, let's move on to the factory floor. So, Dr. Abhinav, you are living this reality every day. So, Atero is demonstrating how waste becomes an asset. From ground up, how do you view the combined market for battery and PV recycling as part of India's emerging circular economy? And what will it take to scale this commercially across ISA member countries? And do you think how can we make this viable?
Sure. First of all, thank you very much for the opportunity and for the invitation. And heartiest congratulations to ISA for establishing the Sunrise platform. I think it's very timely and very important. When you look at solar panels and solar energy, it is not only important that at the time of generation there should be sustainability, but sustainability should continue even as we get into the end of life stage, and which is something which you are doing now and living this particular thing. It's very, very important, and I would like to congratulate you on that. Now, coming to what you asked about, both PV as well as battery, I think it's extremely important that we do efficient recycling of these materials, because there are two aspects to it. One is that there is a lot of hazardous materials which are there, and if let alone, and if it is allowed to decay in the fields, it will be extremely bad for the environment and for the social, the entire society itself. So that's one. The second is there is a huge amount of critical materials which are present, in these, equipment, which need to be extracted back and put back to commercial use. And it's very important given the geopolitical situation which is now emerging globally, and we need to be able to be in control of this. So circularity becomes very, very important. So we at Atero, given that we are recyclers and we have been at this for more than like 15, 20 years, it's something that we see as a huge opportunity, and the numbers that you have shared here is something that we are looking at really in a very, very positive manner. Now, coming to technologies that we have developed, we have been working on solar panel recycling, and we have successfully been able to extract most of the materials which are there in solar panels of all kinds, whether this is aluminum, glass, whether this is gold, platinum, etc., from the chips there, whether it is from the batteries, we are able to extract lithium, cobalt, nickel, manganese. A total of 22 critical materials is what we are able to extract from each of these. Having said that, the point that Rishabh made with regards to the commercial viability and the challenges in logistics, so that's a key challenge which needs to be circumvented. The way that we have been approaching it, while Rishabh did say that we should be closer to the places where the solar farms, etc. are, my own view is that we'll have to go into the solar farms themselves. In fact, what we are trying to design is a movable recycling equipment. And what we would want to actually bring to fruition is a platform which can be moved to the solar farms, and then there at least a first level of recycling could happen where the glass, the aluminum, and so on and so forth could be separated out, and the more the places, the PCBs and wherever there are critical materials, they could be shipped to central places where it could be economically and viably turned into critical materials. So that's something that we see. The second challenge which I would like Rishabh to actually include in subsequent reports that he is sort of going to work on is the fact that there is no clear owner or the financier for this particular operation, right? So if you look at solar panels, and which is different from say plastics or electronics, the life of the solar panels are really very, very large. So 25 to 30 years. And the lifespan of these solar panels are such that some companies which would have installed it might no longer be in existence. And the current EPR mechanisms, extended producer responsibility mechanisms, may not be sufficient for such a thing to happen. So the suggestion that we have made, and to make it economically viable and to really scale the operations, what we need to do is we need to ensure that there is enough and more finances available. And for that, I think at the very beginning, some amount of monies will have to be put into a central depository where it can be sort of then be put to recycling. So that's one. The second is maybe in the same model as in the case of telecom, there was a cess which was charged from the consumers itself, and a fund was created, which then led to the creation of a broadband, network across the country in India. And I think that will be something which will happen globally as well. So a fund will have to be created, which will then accumulate these funds, which can then be used for recycling. So these are two suggestions which I'd like to leave for the crowd. From an Atero standpoint, we continue to be committed to ensure that we make more and more technologies which will be making it viable to be able to extract materials out of it. And that's something that is a commitment that we would like to continue to work upon. Thank you so much for the opportunity.
Thank you, Dr. Mathur. You talked about finances, you talked about funding, and now it's time for ADB. So, ma'am, as you heard, we need to build an efficient recycling hub. And when we do that, we need a major upfront investment. So what innovative structures, maybe Dr. Mathur talked about a solar circularity fund or maybe blended finance tools, could ADB or any other multilateral deploy to crowd in private capital or reduce risk for early movers and make it commercially viable, such technologies?
Thank you, Gurleen. And let me start by thanking ISA for the kind invitation and to be part of this very important session. And I think you've taken the bull by the horns. You know, this is an issue which is very important. And again, congratulations on the Sunrise platform. I like the name also. We are looking at sunrise at the sunset of the equipment and the project. But again, very, very important. And more seriously, you know, you can think of it as a reverse value chain. When we build something, we see how to get different components. Here we are seeing at the end of the life of the project how to address the different components that come out. So, you know, it is a sort of a value chain for me. And actually, my previous speakers have addressed some of the points that I wanted to raise, but more specifically in terms of having a solar circularity fund. As you very rightly said in your question, this fund needs to be sustainable. This fund needs very large investments. So it cannot survive on the basis of grants. So initially, MDBs, bilaterals can look at de-risking and crowding in private investments, but that is only in the initial phase. Long term, it has to have incentives that will make funds flow into this vehicle, if I may call it. So ADB can consider supporting such a fund if there is a request from our developing member countries. And again, some funds exist right now, but they're looking more at R&D, and they're looking more at you know, small pilots. So what's required is a scale-up and blended finance, where you use concessional money to leverage commercial resources. So that brings in scale. Then again, using credit enhancement mechanisms that will again bring in scale. So using a small amount of concessional money, we should be able to leverage a higher volume of resources. Then there was some discussion on standardized and modular plants going to you know, where the facilities are. So again, this modular recycling hubs, you know, these which can be replicated at different locations, or they can go to different locations, will help in de-risking the technology and the scale-up risk. So replicability is very important in my view also. And then any solar circularity fund needs to work hand in hand with the EPR. And the fund would help in ensuring capacity and scalability. So in fact, I was also going to suggest that the policies can consider, you know, a small levy at the point of generation. So let's say we charge, and it's going to be a flat cost, so it would not, for all bidders, so it would not impact competitiveness. But if there was, say, 1 or 2 paisa per kilowatt hour generated, this would then help to build a fund. And luckily, the life here is so long, so we would be, you know, collecting these resources over a period of 20 to 25 years, which can be quite substantial, and address the risk of, you know, the producer not being there at the end of 25 years. So again, and these funds can be reinvested during this period and, you know, further multiply. So again, this is one thing that we can look at. Of course, initially it will have to be, you know, it has to take off with concessional funds from MDBs, from other bilaterals and, you know, GCF, etc. Back to you.
Thank you, Dr. Sujata. So we've heard from policy, we have heard from technology, we've heard from industry, and we've also heard from financial institutions. Now, we know that finance can enable scale, but policy experience can go a long way in ensuring sustainability, and I'm sure all of you would agree to that. So, Bernhard, you have seen how circularity has matured in Germany, and we would like to hear from you what Global South can learn from it. So, Germany's circular economy rests on strong legislation and industrial capacity. So, what do you see as the main structural barriers for developing economies, and how can the principle of EPR, as Dr. Sujata just talked about, and WEEE management be adapted where the informal sector plays such a dominant role?
Yes, thank you very much for this opportunity and for this very nice question. Thank you. Actually, to me, there are two advantages I would see with our German experience. The one is, I think we have a very nice experience in collecting materials, right? So everyone who was in Germany and had a drink of water knows that you pay a credit for this water, and if you give the bottle back, you get the credit back. So this is a very nice collection system, right? So collecting to have the amount of materials that it's economically viable to recycle is super important. So collection is a very important step. Germany is a very small country, and for us it's easy to have these collection structures, right? For the electronic materials as well as for the PV panels, it's the same process. So you pay if you purchase a panel a certain amount, a certain price for the removal and the recycling, and the structures will be in place to collect those materials, to have them in one place, and to go for recycling. So I think the major challenges for the global South, as you ask, to me is to think how collection could be managed in a country big like a world in its own, like India. Or if you think about any other country where the distribution already is a challenge, so how can collection be managed? I think this is a very important point. And the next question is, there's one point where the fund is allocated for the recycling, and this is when you purchase, or the first day you receive your materials, you pay in Germany for the recycling, right? So it's very important to establish an administrative system that those funds will be allocated for an event that will be hopefully 20 or 30 years later, right? So I think this administrative challenge to handle is very important, and to see how the financial mechanism and the time gap between purchasement and recycling could be survived. So in this way, so to me this is somehow something like a guarantee fund, right? So not a guarantee in terms of warranty, it's the guarantee at the end of the lifetime of a material there will be allocated funds to recycle. But actually to me this is a very important point also, because this long lifetime is a challenge, but also our materials should be created in a way that this in economic lifetime should be as long as possible. So the recycling point of those materials should be as far in the future as possible. As we all know from the recycling theory, so the best before recycling is the reuse, and the best before reuse is the use. So I have PV panels on my rooftop, and I hope I will not experience the day when they need to be removed and recycled. I want them to survive, right? So to me, this is the most important thing. And the major learning for me is, and the major discussion we have here in India with my project is the question, what are the quality criteria to make a PV panel survive for 30 years, even in difficult conditions, like on agricultural land, handling with heavy machines. And so to me, this always needs to be highlighted once recycling is a topic. Before the recycling comes, the reuse, and the use should be as long and as extended as possible, to my understanding.
So,
thank you.
Thank you, Bernard, for highlighting some very important points, and my colleague there in the corner would be extremely happy to hear from you about the robust collection systems that Global South countries need to adopt. And also your points on looking at reuse and reliability and degradation of PV modules are also very important, not only for harsh environments, but also for the countries in Global South, which have very different climatic conditions from countries which are in the temperate climate zones or in the Global North. And that is why our session later this day, which is on standardization and harmonization, becomes very, very important as well, and ISA recognizes that. So thank you for raising all these very pertinent points. So Mr. Khanna, we hear from Dr. Gupta that you're taking the bull by the horn with this launch of the platform. So as International Solar Alliance champions solar in Global South, you're uniquely positioned to look ahead. And the sheer volume of end-of-life solar panels, as we have discussed, is often seen as a waste crisis. So through this new Sunrise network, you're planning to reframe this challenge from a waste disposal problem into the single greatest source, a resource optimization opportunity for the Global South. How do you plan to actually do that?
Thank you, everyone, for a lively discussion. Let me, before answering Gurleen's question, talk about 2-3 things. One, I think, Sujata, you mentioned, it's very interesting, Increase, that this is sunrise, because what's unique about sun is that after every sunset, there's a sunrise. So that is a very apt title, that as the solar PV plant is having a sunrise, recycling will ensure there is sunrise. The second, and this is something, let me please share even about a session later on harmonizing standards, that our assembly is a mix of political leadership and technical experts. Why are we talking about sunrise and harmonizing standards in what is sometimes perceived as a technical question? Because I think if we need to find a way forward on issues on harmonizing standards and battery and solar PV waste recycling, we need a combination of political will of countries coming together and technical experts coming on business models. Therefore, we felt it was very apt to actually do it in our main assembly session. The third part, which I think one of you alluded to, is that those of us who have ever dealt with just urban waste management know how difficult the agenda, and when I was hearing Bernard talk about it, in segregating waste. It's one of the most defining problems, that how so many developing countries are not able to do a very good job even on urban waste. The challenges are something similar. A solar PV waste management is not very different in terms of that quality. What is our ambition? Our ambition first is that we must be conveners of creation of an ecosystem. As some of you have highlighted, the standards and business models are not known. They're not even proven in one country, leave about in terms of absorption in other countries. Just as any industry started, whether it was internet, meters, there was a lot of proprietary technology, proprietary issues that didn't allow open sources. we envisage that by having a forum of all the convening countries, we can create an open source kind of a platform where people start sharing, people know, and there is a lot of sharing of knowledge and networks. The second issue is a lot of awareness of what this really means for critical minerals. I must confess, I'm not an expert, but when the team first time presented to me that 90 to 95% of critical minerals can be recovered, I was surprised. Because how many of you know that from a solar PV plant after decommissioning, you can take 90-95% of the materials? Now that's a very important information and in terms of, and third is financing. Already in the panel, some very interesting ideas are coming. A lot of countries have done a cess on fuel to fund a lot of electrification or sustainable. A lot of countries put a fuel on other things. Is that a model? Because we are looking at a 30-year, whether a fund can be created out of some multilateral funds. I think it's very important to have international convening forums to discuss it. So those are some of the issues which is, we feel it's very vital. Those who are already doing a lot of solar, because this problem is going to come very soon, and those who are beginning it can actually plan it while doing procurement.
Thank you, DG, for your remarks and very interesting insight on how we are going to operationalize it in the next 3 years as well. So my next question is going to be for all the panelists here. And this is a closing question. So in one sentence, briefly, please share with us what is the single most tangible deliverable your institution will commit to achieving through or with Sunrise to advance the circular solar future. And I will start it from the left side. Dr. Lee.
In the Sunrise program?
Yes.
Yes. I think of course, if we want to move towards global cycle model, we need to discuss standard of, as we mentioned, the Sunrise program to enable the circulation of cycled material and create a viable solar circular economy model. So some country or some teams can provide technology or financial or marketing or the process. So we have to cooperation, every country or every item or team to cooperation together. Thank you.
Thank you. Mr. Bernhardt?
Actually, from my point of view, with our GIZ project in mind, I would say a vibrant quality discussion could be provided. So the discussion about standards, what is quality, how should it be translated into a standard, and how the sustainability part could be supported. Yes, standards and quality.
Thank you. Dr. Mathur?
Yeah, from a Tero's perspective, I think the, the key expertise that Tero has is of multi-metal refining. And we have some experience of creating technology, creating machines which are more effective for recycling. And as Ashish has pointed out, that there is a great need for technology and a lot of cooperation amongst the various countries of the global south. We would like to be a company which can provide that support. We would like to be that country which can create these technologies and make it available for everybody to use. And that's something that is a commitment that we'd like to make. Thanks.
Thank you. Mr. Jain?
Thank you. I think your final slide had lots of activities. Some of these, of course, we also do in terms of quantifying the waste, etc. But I would say as knowledge partners, very active partners to Ministry of Mines and Ministry of New and Renewable Energy, I would want to link three things: recycling, critical minerals, and solar manufacturing or clean energy manufacturing. One thing that we've spoken about is the reuse. It's also important, how do we design for circularity? And that is where the conversation has to come to the manufacturers itself in the first place. So we'll be happy, because we are also working across the value chain. How do we design these components? How do we design a product that not only withstands the extreme temperatures, but is very easy to recycle by people across the world, even with the lowest skill possible? So happy to work with ISA on that. Thank you.
Thank you. Dr. Gupta?
In terms of, as I said, this is a very, very important topic and very relevant, especially given the exponential growth of the solar industry. So ADB would be happy to include this in our policy dialogues that we have with our partner countries and explore opportunities as to how we can support, as an ADB can support these through our technical assistance programs. And as you know, we are working very closely with ISA, so we look forward to learning from your experience on Sunrise and then sharing it with our partner countries and our continued collaboration with ISA.
Yeah. Thank you so much, Dr. Gupta. DG?
I think...
He has to do all the work.
Yeah, exactly.
I mean, what are you asking him for? One contribution.
Yeah. No, it's a business model. I think in all ecosystem creations, a business model that is financeable and can get the cost-benefit analysis. That is something that we are going to then share with everyone.
Thank you.
Actually, she will have to do everything.
So I'm bringing it upon myself. So thank you so much to all our panelists for an incredibly insightful and forward-looking discussion. So what we've heard today is not just a series of perspectives, it's a blueprint for new solar revolution. We heard from ISA's vision. We saw how Global South can lead this next frontier, redefining end-of-life solar as a resource opportunity. From CEW, we have heard the need for strong policy design with regional recycling hubs, and that circularity begins at the drawing board, not at the landfill. ITRI reminded us that technology is a real game changer. Innovations in design, dismantling, and recovery are already proving that solar materials can live multiple and long lives. ETRO recycling showed us that this isn't just theory. With modular recycling hubs, circular business models are already creating value. And ADB brought in the missing link, finance. To make circularity real, we must turn it from a compliance or levy cost into an investable opportunity. And GIZ reminded us that Global South doesn't need to start from scratch. We can learn from decades of global experience in collection, in terms of standards, harmonization from Germany's work, and adapt what works for Global South. So the Sunrise platform, especially its community of practice, will be bridging this connection and connecting all these dots through next 3 years, linking data with policy, technology with investment, and vision with action. So as we close this panel discussion, I want to echo one powerful thought. The solar journey doesn't end when a panel stops generating electricity. That is where a new chapter begins of recovery, generation, and reimagining value. That is really important. So the waste of today is the resource of tomorrow, and opportunity to grab that is now. With this, I would like to close this panel discussion, and I would hand over the mic to Director General ISA, Mr. Ashish Khanna, for his strategic remarks on Sunrise. Okay, so we would like to bring this session to close. And for that, I would like to invite Honorable Minister Abdoulaye Jinapur, Minister of Energy and Green Transition, Republic of Ghana, to deliver the closing remarks and our collective call to action.
Thank you very much, Your Excellencies, distinguished delegates, colleagues, friends, members of the media, and everybody gathered here. Yesterday, I arrived here, and this morning, DG asked me whether this was my first time of coming to India. And I told him, no, this is my 6th time of coming to India. So I may as well qualify to have a green card so I can always come to India. It's been very, very inspiring. We had the President herself, our big brother, the minister. He spent the whole day with us. We're exceedingly grateful. It tells me the seriousness with which he attaches to this whole exercise. And I find it very, very inspirational. As we conclude this very, very inspiring session, I am filled with optimism, and I am resolved that we will make progress from this very, very 8th session. There's only one thing I look out for. DG, and this goes to you. Next year, by the time we meet at this time, I want to point out to some projects that we've undertaken with you to ensure that this whole exercise transform into the lives of ordinary people, particularly in my country. The launch of Sunrise, the solar upcycling network for recycling, innovation, and stakeholder engagement signifies a pivotal moment for the International Solar Alliance and marks a defining step towards the next phase of the global solar revolution and serve-to-serve cooperation. Today, we've heard from diverse leaders across policy, industry, research, and development who have underscored a clear and vital truth. Transitioning from solar power to solar circularity is essential and not an option. To fully realize a sustainable clean energy future, solar technology must incorporate solar economy principles, covering design, deployment, reuse, recover, and regeneration to truly make our green transition sustainable. And when we went for lunch, I learned a lot. I learned a lot from all the countries that we sat with, and some of the innovative technology that they are adopting in order to ensure that we supply clean, sustainable energy for our economic development. Through Sunrise, ISA demonstrates leadership by converting challenges into opportunities, creating new industries, securing critical materials, and promoting inclusive green growth, particularly in Africa, where we need this energy the most. Small island developing states and small economies can benefit immensely from solar deployment. For Ghana and many African countries, this initiative is both an inspiration and a practical partnership. Establishing regional recycle hubs, knowledge networks, and circular supply chains will certainly unlock significant value, which measures not just by recovered materials, but is measured by the jobs we create, by innovation, and sustainability for our people. I commend the International Solar Alliance. I commend the government of India. I commend you, Minister, and I thank you very much. And I commend all partners for shaping Sunrise. This platform embodies the spirit of shared responsibility and prosperity that defines those of us in the ISA family. Let us recommit today to ensuring that every solar panel, every battery deployed, powers not only the grid, but also protects our planet's future. Together, let us transform solar power into solar circularity, turning waste into wealth for our economies, for our environment, and generations yet to come. Once again, let me thank you and to thank all the panel members for the insightful and knowledge that you've exhibited. Thank you very much. I'm grateful.
Dear Honorable Minister, thank you for your closing remarks. And I would like to once again thank everyone on the podium and all the panelists for a very engaging and interesting discussion. And with this, I would like to close this session. Thank you.